Past paper questions. We're going to start with this question about paradigms. Now notice there's a decent few marks available for this, so it's not one of those questions you can just skip over. 7a, explain what's meant by the term programming paradigm. So the technical answer for this is that a programming paradigm describes the different types of approaches in programming language. There's a mark for that part, that are needed to solve different problems more effectively. Okay, so that makes sense, doesn't it? It's breaking it down into two parts, but essentially the basic solution is there. It is different ways of programming to help solve different types of problem. Part B, describe the difference between procedural and event-driven programming paradigms. Okay, so procedural, you'll remember, let's define that first. Procedural languages are those that solve a problem in a linear fashion through a sequence of step-by-step instructions and involve the use of selection, iteration, and callable procedures. So that's us describing the sort of programming languages that we are used to using, the sort of development that we've been doing probably since all the way back in GCSE. Procedural languages are very suited to problems that require a linear algorithmic solution. So what does that mean? That means if you can think through the solution from start to finish in a single process, they are a very useful way of building software. However, some software is not linear. Some software you can't just click go and let it execute. Video games, things that require a user interface are different, and we don't know in which order they will be used. Event-driven programming then is used to solve problems that require heavy user interaction, maybe through a graphical interface. Listeners are attached to objects, so basically we attach a method to an object that listens to see if it's been pressed. If it's a button, if it's been clicked, it will in turn execute a subroutine based on the type of event that's triggered. If you've done any UI programming at all, you will have come across this. Event-driven programming languages are more suited to problems that require rapid application development and a graphical user interface. Essentially, we're talking video games or anything with a UI. Part C then, using examples, describe which programming paradigms would be most suitable when developing different types of software applications. It's a 4 marker, we want 4 discrete points here. So, here's some indicative content. One is that OOP could be used in the development of a large distributed software application that requires a large team of developers. So having the idea to make classes there, it would be very, very suitable to that. We could have event-driven programming, which is good in the development of a graphical user interface. Logic programming could be used in the development of artificial intelligence. That's a specific purpose programming language. And then functional programming could be used in the development of software applications requiring complex mathematical transformations. Procedural programming could be used in the development of command-line interfaces, and so on. There's a bunch of indicative content there, but what indicative content means is that that is not an exhaustive list. The entire list we looked at in the recap would be suitable to bring back in this point, as long as you're giving a realistic example of each. On to question 11 then. Question 11a, describe what's meant by a class and an object and describe the relationship between them. So clearly there are 3 things to talk about here, but 4 marks. Let's see where those 4 marks come from. First of all, we're saying a class is a template or blueprint for a specific object. It defines an object's variables, their attributes or their properties, and their behaviors, their methods. An object is an instance of a class. So where did the 4 marks come from? You get a mark for mentioning the template key to describing a class. There's a mark for defining variables or properties is the correct word for them in this case. There's a mark for defining the behaviors or the methods is the correct word in this case. And there's a mark for stating that the object is an instance of a class. Now what normally happens in this question is people get the first and the last mark and miss out on those 2 parts in the middle because they just don't really focus on the fact that the class by its very nature has properties and methods in it, and they forget to mention that. Part B, describe what is meant by the term method and describe the relationship between the object and the method. Well, a method is a programmed behavior that is included in the object of a class. A method can only access data within its own object, and that's the idea of encapsulation. And so you remember from the summary that the point of encapsulation is that if we want to change the properties of a particular object, that we have to go through a bunch of code to do that. And a good example of this is maybe a character in a game. It wouldn't be a good idea to have other objects just change the health of that character, because we want to have a check every time that health was changed to see if the character had died, and to play the death animation and to remove it from the game. If we just allowed them to change the health, it would probably go below 0 and we wouldn't notice. So where are the 2 marks coming from here? The first mark is for saying that the method is the behavior or the subroutine, and the second is for mentioning encapsulation. Another question then, this one's all about unambiguous syntax. Part A, produce an appropriate syntax diagram to define a constant in this language. So what do we need? A constant must be either a single uppercase letter or a single uppercase letter followed by one or more uppercase letters or digits. So syntax diagram wise, this is reasonably straightforward. We've got an uppercase letter followed by, and there's a bunch of paths here, it could be straight out, you'll notice it goes underneath there. It could be a single uppercase letter, but if we've got that, we go back and we can have another one, or we can have a digit and we can go back and have another one. So there's an infinite amount of those two things there that we can have, but at least one of them. Where do the marks come from there? So 1 mark for the compulsory uppercase letter, that's the first box. 1 mark for optional uppercase letters or digits. 1 mark for nothing or a skip arrow, and 1 mark for repeating the uppercase letter. So there must be an arrow looping back there to go back, and those arrows are important to show the direction in which you can travel. In BNF then, that's a little bit more complex. You have to first of all define your uppercase letters. Now, of course, in the mark scheme they've got an ellipses there to say and everything in between. Doesn't mean anything special, that's just they're not willing to type out all the letters. Same for the digits, they're not willing to type out all the digits. Now, I imagine that you could have done exactly the same thing in the exam, but I wouldn't be sure. I'd always be tempted to write them all out just in case. A string then is either going to be nothing, or an uppercase letter, or a digit, or an uppercase letter followed by another string, make it recursive, or a digit in a string, and that's the most complicated part of the entire thing. And then the constant is going to be an uppercase letter followed by a string. Remember, the string can be null, it can be nothing. Now, you can't get full marks unless it's completely correct. If the BNF notation is used wrong, your answer's not correct, so you get no marks. There are alternative solutions, and I think there's probably a nicer solution there that involves using an or in the constant.